Students, in this session we will talk about friction. Friction plays a major role in working of mechanical systems, and understanding how friction plays an important role ensures a better design. So in this chapter we will talk about what is friction, what is the cause for the friction. We will also talk about different types of friction, when to take what, so on and so forth, certain other parameters which comes into play, and also we will define how to compute the friction. We have heard of people saying, like in your school you should have studied, no friction you cannot walk. Walking in ice is difficult. The reason is ice is a frictionless surface and you tend to slip. So friction ensures the body doesn't slip. We'll see more examples when we get into the subject. So what is friction? Friction is basically a contact force. It comes into play when there is two surfaces come in contact, and they are not just in contact, they are about to have a relative motion between the two surfaces, or they have a relative motion. The friction resists the relative motion between the two surfaces. Friction can be classified as static or kinetic. Static is when the surfaces are at rest and are about to exhibit a relative motion, while kinetic friction is one in which the object is in relative. There is a slight difference. Static friction is more than the kinetic friction. We will see a small video which demonstrates what friction is all about.
To look at two kinds of friction, static and kinetic friction. Now, here's an example of kinetic friction. If I push this brick, it slides across the table, obviously, and comes to a stop. Something is bringing it to a stop. We take that to be a friction force. Now, since the brick is moving, that's called sliding friction, or another word for it is kinetic friction. Now, the characteristic of kinetic friction force is that the force always acts opposite the direction the object is moving. So the brick moves this way, the kinetic friction force is that way. All right, let's take a look at another kind of friction force. This one an example of this one is the force between the tires of a car and the road. Let's get this car going. Now, the force that pushes the car forward along the road, is a friction force. Now, that may seem like a strange thing to say. After all, isn't it the engine that moves the car? Well, you certainly need the engine in order to move the tires, but you need the road in order to move the car. To see why that's true, suppose I turn on the engine. But with no road, it doesn't go anywhere. The tires simply spin. The road provides the friction. What's actually happening when the tires are in contact is that the tires are pushing backward on the road, and the road is pushing forward on the tires. This is an action-reaction pair of forces that acts according to Newton's third law. So tires push back on the road pushes forward on the car, or on the tires. And that push force is a friction force. And in this case, we call it a static friction force. We use the word static because static implies no motion. Now, it's not that the car isn't moving, it certainly is, but the wheels are not slipping along the roadbed, at least not in normal operation. Now, here's another example of static friction. Let me put an object on this brick. If I tilt the brick a little bit, the object stays there. Well, what keeps it there? It's a static friction force. There's no motion between the bar and the brick. Now, if I tilt it enough, the bar begins to move, and so the static friction force became a kinetic friction force at that particular point. One more example of static friction force has to do with the force required for us to walk. In order to walk across the floor has to push you forward. It's a static friction force. What's happening is that your shoes are pushing backward on the floor, and the floor is pushing forward on you. Again, if that seems strange, just imagine that there were no friction between you and the floor. Maybe it's an icy surface, or maybe you're walking on ball bearings. In that case, you simply slip and fall. You don't go anywhere. So you can try as hard as you want, but you're not going to move. So you've got to have that static friction force between your feet and the ground in order to move. So static friction is necessary for human locomotion, at least the kind that we normally do.
What causes the friction to come into play? Basically, we'll see when two surfaces are smooth, they slide one over the other with ease. So when the surface is rough, you need to have extra force to make the motion happen. this extra force which you give is the friction. So the cause for friction is irregularity in the surface. If the surface is smooth, the friction is less. The reason is, any surface, if you look, they have undulations, and because of the undulations there is interlocking, or there is a mating between the two surfaces, and this interlocking is more when the surface is rough. So this means that you need to have more force to push it. Here is a small video which shows you how friction comes into play and what is the effect of the surface finish.
Let's discuss it a little more. A surface is never perfectly smooth. Even very smooth surfaces possess irregularities, which is visible only through a microscope. So when two bodies which are in contact with each other, the irregularities present on their surfaces tend to interlock with each other. Now, when we try to move one of the body on the surface of the other body, the interlocking of irregularities opposes the motion. This opposing force is called friction, and its magnitude depends on the degree of irregularities on the surfaces in contact, while its direction is always opposite to the direction of motion. Thus, friction is defined as the force which opposes the motion between any two or more surfaces in contact.
Having seen the cause for friction, we will talk about what is meant by static friction. As I said earlier, static friction exists between two stationary objects which is about to perform a motion. The friction force may have a value which starts from 0 and it takes up a maximum value. That is why we say friction is a self-adjusting force. It adjusts to whatever is the force which is applied. It takes up a value from friction can be 0 and it could be a maximum. When it is maximum, we call it as it's a limiting friction. Here is a small video which gives you more idea on what is static friction.
Look at the equation for static friction. So static friction is a case where you've got two solid surfaces in contact and you're trying to move between those two surfaces. So you're trying to move one surface across the other. But the objects don't slide relative to each other. So you're attempting motion, but you're not succeeding at moving things. In other words, the static friction makes them stick together. Well, the equation that represents that is given here. Now over here on the left-hand side, we have our frictional force. Now, the way our textbook uses this, it's a lowercase f with a subscript of an s. Some books do have an uppercase f, but we're using a lowercase f. Over here on the other side, we've got the normal force, so that F sub n is your normal force. This is our coefficient of static friction, and that's the Greek symbol mu. And because it's static friction, it has the subscript of an s. We've got another video for talking more about that coefficient. The last thing I want to point out about this equation is that the symbol in the middle here is not an equal sign, but a less than or equal sign. So we want to explain that. We're not used to having inequalities in our equations here. So less than or equal. The force of static friction is only going to be as much force is needed to hold it still. And that means if you're attempting to push it, but you're only pushing a little bit, it only needs a little bit of friction to hold it still. If you push a little harder, then the friction has to increase to keep it from moving. Well, there's a maximum, and that maximum is when it actually equals mu sub f Fn. So up here you're going to have less than mu sub f Fn. But here there's a maximum amount that you can push. If you push too hard, more than that maximum amount, then friction can't hold it still, and we do not have static friction anymore. Because static friction has to hold it still. So there's a maximum amount that we can have, but anything else you're going to have less than that maximum. So this is our introduction to static friction.
While kinetic
Now we're
friction
going to talk about the equation for kinetic
comes into
friction.
play when there is a relative motion between the two objects, and kinetic friction is a constant. It depends only on the coefficient of friction and the normal reaction, as said in this video.
So in kinetic friction, we still have two solid surfaces that are in contact, but in this case we have motion between the surfaces. Because of this, kinetic friction is also sometimes called the sliding friction. So you have one object sliding across another object. The kinetic friction will impede the motion, but they do actually move past each other. Now the kinetic equation is what's shown here. Now this is a little bit similar to, but simpler than, the static friction equation. So if you haven't watched that video, you should go look at that one as well. Over here again we have the frictional force, but you'll notice that we've got the F sub k, where the K stands for the kinetic. Again, our textbook uses the standard of a lowercase f for frictional force, as opposed to the typical uppercase F. Over on the other side, we still have the normal force. And now we have the coefficient of kinetic friction. So you notice we've got our mu, but the mu has a little sub k on it. So this lets you know that you should be using the kinetic friction coefficient as opposed to the static coefficient. The big difference between the static equation and the kinetic equation is the symbol here. For kinetic, it's always exactly equal to. You may remember on the static case, it was less than or equal to, and you had to just sort of figure out how much force was needed. But in this case, it's exactly equal. So if they're moving, you know exactly how much frictional force is there, provided you know the coefficient and the normal force. So that's our introduction to kinetic friction, the equation. Again, you'll need to actually work some problems.
The other things which you should know is what is called as
of the granular material is the steepest angle of descent or dip relative to the horizontal plane to which a material can be piled without slumping. At this angle, the material on the slope faces on the verge of sliding.
So angle of friction plays an important role. It tells whether the object is about to slide or it is at rest, depends upon the force. It is basically angle of repose, which talks about a condition in which the inertial component is greater than the frictional component. With this brief idea on friction, in the next lecture we'll talk about how friction is useful in functioning of various mechanical systems. Thank you.